Development of a speech-to-text program for people with hearing impairments. The appendix developed a system that recognizes the speaker's text and translates speech into text. Yes, people with hearing impairments will be able to hear the interlocutor and understand him if he does not know sign language. The program provides the following. First of all, the user or person with a disability opens the program and includes the function of text recognition from the person with whom he communicates. And also the program translates speech into text. Relevance of the topic is the need to describe and develop a system of communication between people, some of whom have hearing impairments, which is gaining popularity in the world and is used in many countries to help people with disabilities. Describe and develop a system of communication between people, some of whom have hearing impairments. Consider the application of speech recognition, neural networks, machine learning to transform speech into. Based on the described structures, diagrams, block diagrams, etc., develop a CLON application. The object of research is a means of communication between people, some of whom have hearing impairments. The practical value of the result is to develop and test new tools and methods for converting speech into text, saving human resources and money, and building convenient, useful, and important for people with hearing impairments software and system. Let's analyze the capabilities of the developed software product in comparison with modern analogs. Programs similar to those present on the market are products of foreign production. Roger Voice, Live Transcribe, App My Ear, Ava, and Voxky. Roger Voice is the world's first mobile application for creating subtitles for telephone conversations, which converts mobile voice calls into a much more accessible text format, developed by deaf engineer Oliver Ginell. The second one is Live Transcribe. The application reads human language and translates it into text. To do this, the application uses a smartphone microphone and Google's Language API, which supports more than 70 languages. To ensure that the transcription is as error-free as possible, machine learning technologies are responsible for recognition. The third one is the My Ear app. It was developed by Gerald Aesop, a deaf golfer, and his son Brandon. Gerald grew up reading clips but was disappointed to understand only 30% of what he said or heard, and got tired of asking people around him, "What are you talking about?" This program was created based on these frustrations, a program they used to communicate with their hearing colleagues, friends, and family. Then we have Ava. Lip reading can be more difficult in a group of people, and this is one of the main reasons for creating Ava. If a person who is deaf or suffers from hearing problems is with a group of friends, he or she can force those friends to join the program. Then the person or persons with hearing impairments will see the live broadcast of the group conversation. Then we have Voxky. It's a language-to-text program that converts voicemails message into text and emails that you can store, search, and share. Vox Sciences provides a paradigm shift by transcribing voice messages into text messages. I suggest you to compare and estimate analogs with the developed product by means of the following tables: Roger Voice, Live Transcribe, Ava, and others. Applications will be compared. All evaluations will be conducted on a scale from 0 to 5 points. The comparison will be based on the following characteristics or requirements: compliance with the purpose, ease of use, pricing policy, tariffs, practical use, simplicity of design, network requirements, the complexity of manufacturing, development, design, control panel, parameters, and support. The applications being developed will be evaluated against the requirements it will meet. Other characteristics will be evaluated according to the developed mockups or prototypes. Here we can see two tables. The first one and the second one show us points which was given to every of the app. The target audience of the applications includes the following groups of people. First of all, developers, business analysts of the applications. The second one is users, people with hearing impairments, and also sponsors. Application languages, two language version of the application, Ukrainian and English. What about basic success scenario? The user installs the CLON application, the user logs in or registers in the application, the user gets acquainted with the settings and interface of the application. The user selects a live broadcast recording point, then application shows the user the text that had just been spoken. The application analyzes the text and offers quick answers. The user selects one of the suggested answers or select a typing item independently. The main times of work in the application. The system receives speech from a person, then the program processes the converted speech into text. At the stage of development of functional requirements, the following list of functions and their attributes was created. It was decided to follow the principles of flexible software development methodologies, which is why the first version of the product will implement a miniature of the following functions. Non-functional requirements. You need to provide user supports when working with the application. Also, you need to ensure the future use of text-to-speech. You need to provide offline support for the program, list of required technologies, and additional devices. The application must be designed as an application for the phone. The user can transfer data to be read through the microphone. To finalize the usage diagram for this model, follow the steps. Here we have two diagrams, diagram of use cases and diagram of classes. You can use it to finalize the usage. The next one we have the sequence diagram is constructed from the classes of the class diagram in chronological order. So we can see that the user of CLON can log in or register, check the data, choose the convert speech to text or show settings, and so on. Here we have deployment diagram. To complete the deployment diagram of the design system, you must add the remaining nodes and connections. To do this, follow these steps: nodes, application clone, and serves, API text analysis, connection between servers and host. Here we can see the prototypes of applications. First one is a prototype of the entrance, and then we can see the main program window. Next, the program must analyze the text so that the user can provide a quick response from the proposed options, which will be voiced. If the user does not find the right answer, he can type the text and it will be sounded through the phone speaker. The first version will only receive speech from the user and translate the speech into text. The first example will look like this. The user will be asked to say something. Say something. After that, there will be a pause of 3 seconds, after which the speech will be interrupted. After that, the user of the application will see the text that was said by another person. Text to be spoken by its user. Hello, it's my first program speech recognition app. And then you will receive this type. CLON speech recognition thinks you said. Hello, it's my first problem speech recognition app. So what do we have in the results? Testing will follow these steps. First of all, check individual words, then check certain phrases, and then check whole sentences. Check more than 2 sentences. CLON speech recognition thinks you said bye. The result does not fit bye. The next pronoun is you. CLON speech recognition thinks you said yo. The result is just as disappointing. Recognized word yo. The next pronoun is he. Clone speech recognition could not understand audio. The result is the application cannot recognize what was said. The next pronoun is she. CLON speech recognition thinks you said skip. So let's discuss. First, let's check the pronouns. The first pronoun to be checked is I. CLON speech recognition thinks you said bye. The result does not fit by. The next pronoun is you. CLON speech recognition thinks you said yo. The result does not fit yo. Thus, we can conclude that the more words, the better the recognition. The text is self-correcting, and it's possible that the artificial intelligence itself can correct or add the right words. So what can we say for the conclusion? In the last few years, the demand for communication applications between people has been growing because it's a fast way to communicate. Modern messengers are used for messaging, but their idea prompted people around the world to create similar applications for people with hearing impairments. This is one of the first and defining steps to solving the global problem because people with disabilities live among us and also want to communicate. Not everyone understands sign language and not everyone can immediately understand that a person has hearing problems, though this application is very necessary. The system developed a system that recognizes the speaker's text and translates speech into text. Yes, people with hearing impairments will be able to hear the interlocutor and understand him if he does not know sign language. Therefore, the developed application can and should be improved by expanding its functionality for further use in commercial companies seeking to help people with hearing impairments. Thank you very much for your attention.